If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture on gate electrical circuits. So today we will be solving again 5 questions from question number 156 onwards up to question number 160. So some of the questions we have gone today up to two-port networks also, in two-port networks. Okay, then let's try to solve these questions. Okay, in question number 156 what they have asked, find the network given below. For the network given below, the Thevenin's voltage VAB they are asking. So for VAB, what you can do, you can apply KCL, KVL, Nodal, whatever. So we need this voltage. So obviously what thing you can do, you can go for a nodal analysis considering this is Vx, suppose this node is V and this one you already know, so there is no need, and this is your reference node. So you can write two equations here and there and you can solve it. Or whatever you can do, you can convert this one into a voltage source, conversion of current source into voltage source, that also you can do. In that, with one equation it can be solved. But if you are not doing that conversion, you can use two equation, whichever you feel good, you can do with that one. So if I apply that nodal analysis, then it will be, for this I am writing V minus Vx by 10, that is this current, then V plus V by 5 plus 6 equal to 0. So this is one equation, and if you write for equation for this one, it will be Vx minus V by 10 and then plus Vx by 10, this current, plus Vx minus 16 by 10 is equal to 0. So you can find V here, solving these two equations you can find Vx. I think if you find Vx, it will be minus 1.5 volt. Okay, next question number 157. So in 157 what they are asking, this is from two-port network. We have started two-port network. So in two-port network, if the two-port network is reciprocal, then we have with the usual notation following. So in two-port network you have GH parameter, hybrid parameter, inverse hybrid. First parameter is Z parameter. I think you should know all these parameters. Let me give a little brief of this one. V1, V2, because it is Z, so it will be, we can think it V equal to IZ. So this is the first parameter you will find, Z parameter. I am not writing it is Z11, Z12, Z21, Z22, and this is I1, I2. So you write it as simple, it is V is equal to Zi, or you can write V1. So this is your Z parameter. Question is Y. For Y you need I1, I2. So I is equal to Y into admittance into V, V1, V2. So these are simple Z parameter, Y parameter, impedance parameter, admittance parameter. Next is your hybrid parameter, H parameter. For H parameter, this from here V1 will be there, and from this side it will be I2, and here it will be I1 and then V2. So this is your H. So similarly your G will be equal to, from here it will be I1 and it will be V2, and here it will be V1, it will be I2. Just inverse. So you can think H is coming from, first one is from here, mix of these two is hybrid. So H from here and I from here, the first one from here and the second one is from second one, and this one just inverse of this one in place of B. So this is hybrid, inverse hybrid, and last one is ABCD. ABCD you know, this is ABCD, this is in transmission line, you must have seen of I1, and this is minus I2. So take care of this one. In case of ABCD it is minus, and it is this is the power, sending end power, V1 I1 is equal to V2 I2, sending end and receiving end. So this was the relation between these two. Okay, now for reciprocal and inverse, you remember this one, reciprocal network. For all these I am writing a short note so that you can remember. So for reciprocal and symmetrical, if it is a Z, you can see symmetry means it should look same from one side, from 1 and 2 it should look same. So your 1 input from one side, 1 is your input impedance, actually V1 by I1 you will get. So 1 should be equal to 2, that is your, from 1 and 2 both should be same, both should be symmetry. Similarly Y11 should be equal to Y22. So for hybrid parameter, each was H11, H21, H22, all determinant should be equal to 1. Similarly for determinant G11, G12, G21, G22, this determinant should be equal to 1. And transmission network, you already know A should be equal to D. For transmission network, we have seen in transmission parameter ABCD, A is equal to D, because from input side and out it should look same, symmetry. From whatever you give this side it should come. from that side, and if you give that side, it should come this side. So that is a symmetry between input and output. You can remember in that notion itself. Reciprocal is 1 to 1, 1 to 2 1. So you remember this one. You say you take reciprocal 1 2, it will be 2 1. So y12 should be equal to y21. And similarly, this one will come later. h12 is equal to minus h21, and g12 is equal to minus g21. And in ABCD, the determinant should be equal to 1. So this one you can remember. So from this you can directly write here. If you remember this theory, this one you should remember. So here we have a usual notation. So reciprocal it will be, what will reciprocal? h12 is equal to minus h21. So this is your answer for here. So this is a very standard chart. You remember this one. For the two-port network shown in figure, the admittance matrix. So for admittance, this is your admittance matrix. For admittance matrix, you need a relation between I and V. So what best, that means I1 can be written in terms of V1, V2. That means you need an expression of V1, V2. So what can be the best expression for V1, V2? Which if we go for, we can write directly expression for V1, V2, because this is V1 means this terminal, this node is V1, this node is V1, nothing is there, and I1 is coming here. So the best way is to write KCL at here, or you can think of nodal also, whatever. That means I will be writing nodal here, considering I1 current coming from this side, considering I2 is current from this side for V2. So if I write the nodal equation 158, so in 158, so if you see this one, your I1 is coming. So if for this node, incoming is always negative, so I will put minus that later on. So V1 by 10 and plus V1 minus V2 by 10. So V1 by 10, V1 minus V2 by 10 should be minus 1 is equal to 0. Or you need I1 equation. Your I1 is equal to V1 by 10, V1 by 10. So it will be 2 V1 by 10 and then minus V2 by 10. I've simplified this one. I1 is equal to. Similarly, if you go for I2 here, so it will be V2 by 10 plus V2 minus V1 by 10 minus I2, because I2 is incoming, for nodal outgoing is positive. So which is your I2 will implies minus 1 V1 by 10 minus V1 by 10 plus 2 V2 by 10. So now you can easily write using this matrix I1 I2 is equal to Y admittance matrix. So which can be written as I1 I2 is equal to this Y matrix 0.2 minus 0.1 minus 0.1 0.2 into V1 V2. This is your no option. This is directly you have to write the answer. Okay. In 159, two-port device is defined by the following pair of equation. This one, the impedance parameter Z1. So there is a relation between impedance and admittance parameter. Impedance parameter is inverse of admittance parameter. If you find admittance, then you can take inverse. You will find Z. Z matrix, Y matrix. In your transmission line also, in fault analysis, power system also, we have done this way. So this one can be done. So here if you see, it is given at admittance parameter, because I1 I2 direct relation is given. So I1 I2 I can write it 2 1 1 1 V1 V2. That means you know Y. This is your Y. So what will be Z? Inverse of Z. So for 2 cross 2 you can write directly the inverse. What is the shortcut? For 2 cross 2 inverse these two. So it will be 1 2. This will change this position, and this will change its sign. Their sign change. Here I can write sign change, and this diagonal position change. So this is the shortcut for writing 2 cross 2. So this side it will be minus 1 minus, because it is plus 1, so it will be minus 1 minus 1, and divided by its determinant. Determinant is 2 minus 1. 2 into 2 minus 1. So if you change, or you can do it to matrix inverse, whichever. So there is a shortcut, you can write it, or you can do it. So this is your answer. That is option B. In question number 160, what they are asking, a passive two-port network is in steady state. Now you take care of this word. Passive means there is no active. Active means there is no source inside it. Active source, which is not generating. There is no generating of power inside that network. Though no active part. Active means which is delivering the power. So no such item is there inside that network. Is in steady state. Compared to its input, the steady state output can never offer. So what cannot be changed from input to output? Voltage can be changed, because transformer is not an active device. Lower impedance, that can be also done. Greater power, Impedance matching, there can input impedance is high, that is in transistor you will see input output impedance differs. Greater power, this one you can see greater power, that means input side is small power, output is great power. That cannot be possible because inside there is no power generating unit, no active source. So whatever power you are giving, the output power will remain same. So there is no chance of getting greater power. So it is option C. This is not possible. If you like the video, then press the like button and please give your valuable comments in the comment section.